So what I'd like you to do is you begin today's video in the front cover of your notes. Please write these 4 equations down, and then right behind each one I want you to tell me what it looks like in slope-intercept form. So here you are going to want to distribute first and then get the y by itself. Again, distribute first the 3 and then get the y by itself. And write these equations, each one in y equals form, and see which one matches this graph below. What we're trying to get you to think about is different forms of the line. So if you pause the video and try writing each of these, and then you'll see my solution. Notice they all work for this equation. They are all going to come out to be y equals 3x minus 5. If you did not get this, please make sure when you get into class tomorrow that we take a look at it and see that you're making sure you understand. In our lesson today, lesson 3, point slope form, here are the 4 standards that we are looking at. This is lesson 5.4 in your textbook, and the I can statements that we are looking at is that I can write it in point slope form, I can rewrite in point slope form, I can identify the point slope form of a linear function, so looking at this key equation, and then I can graph in point slope form. So we've learned how to graph in slope intercept, where we use our intercept and then slope. Now we're going to use the point x1, y1 and our slope for an easy way to graph. So point slope form of an equation of a non-vertical line with a slope of m is this equation. When you have a point x1, y1, you're always going to have y minus whatever point this would be, that's our y1, equals m times x minus x1. Now this is called point slope form because you start with a point and you're given your slope usually. The nice thing about this is if you think of what's the definition of slope, the definition of slope is the y coordinates divided by the x coordinates, which is what this would be if we solve for m. So when we look at the symbol part of this equation, what we are looking for is this y1 is going to be our y coordinate, whatever that happens to be. This is going to be our slope is m, and the x1 is our x coordinate. Now a lot of times they will give you that as a starting point when you are looking at these equations. So a line through, we want to write an equation point slope form for a line through negative 3, 6 and has a slope of negative 5. First step I need on your paper is this big equation. You must have this down first. Then you want to be thinking, okay, I'm going to replace. Now one thing you really want to take notice of is that when you look at these equations, this is always, always, always a minus. So you got to be careful for that and watch the sign. So on our x and y, our y is 6, so it's going to be y minus 6. Slope is negative 5, x, and then it's minus a negative 3. Well, remembering minus a negative becomes plus 3 in simplest form, so this is our new equation. I would like you to look at this example up here and kind of see if you can get it. Here's our x, y point, x1, y1, and our slope m is 2/3. What is our equation? First step, start with y minus y1 equals m times x minus x1. Substitute in y point is negative 4. Y minus a negative 4 equals our slope 2/3 times x minus our x point is 8. The only thing we need to do to finish this equation is simplify is y plus 4 equals 2/3 times x minus 8. And again, if you want to fit this in first, key thing I need to see on your paper, you must write this equation first. The other thing I would like you to make sure you're doing is identifying your x and y, like putting the letters above it. I think that will help you a lot as you do the problems. So now, how do we graph point slope form? We just learned in the last lesson how to graph with slope intercept. What you're going to do when you look at this is, in order to graph, you're going to use your start point as the point that they give you. Well, in the equation, they don't really give the point, so you have to write the point from the equation and use the slope. So the first thing we're going to do is make sure you have, again, this equation written down. Because if it's y minus 1, that means that our y is actually a positive 1. And here it's x minus, and it's x minus 2, so the 2 is going to be a positive 2. Remember, the sign doesn't go with it. It's always a minus sign when you look at that equation. So because this is minus 2, we're just taking the ordered pair 2, 1 as we look at that. Next thing you're going to do is, this is your starting point. We start at 2, 1, and then we go back to using our slope again. Rise of 2, run of 3. We cannot go up 2 again and over 3 and be off our graph, so we could go down 2, that's negative 2 going down, and back 3, negative 3, and now we can draw our line. It says use the point equation, use our slope to find another point. This is really the same thing as when we did slope-intercept form. Only thing in this one, instead of your y-intercept, you start at a point, and you still use the point to get more points on the line and draw your line. So if you are asked to graph, just like we kind of did in slope-intercept, first thing we want to take a look at in this equation is we want to think, okay, what is, if we are looking at this, our equation? Well, remember, let's write it down. Y minus y1 equals m times x minus x1. So in this case, first thing we want to identify is our xy coordinate point. What is the point? Well, it was a plus 6. Remember the equation must be minus, so it's a negative 6. So our x is going to be negative 6. What is our y going to be? Oh, it's already a minus, so it is simply going to be 4. Our starting point is at negative 6, 4. Take a look at this graph, look at the scale. It goes up by 2s, not by 1s, so you need to be really kind of careful for that. Once we have that, it says that the rise, our slope, is a negative 1/2. Now, we know if the slope is a negative 1/2, that is key for telling us that it needs to go down to the right. Okay? So we know we can't be going up. It is telling us to go as a rise of down 1, and then a run of 2 to the right. So even though this is a scale of 1, we can still go, since the scale is 2, we could go down 1 and over if we are looking at this. We could go down 1 and over 2, down 1 and over 2. Does it make sense that these points work? Well, let's check. Does negative 2, so when you draw your line, does this point, negative 2, 2, work? So how you can always check if you did it right, remember, all of these points need to make it true. So if we go to our equation and we put in y minus 4 equals a negative 1/2 times x plus 6. Remember, beginning of the year, we always checked our equations. This is our y. 2 minus 4 is a negative 2. Here, the question is, does it equal a negative 1/2 times negative 2 plus 6? Well, negative 2 plus 6 is going to be 4. And if we take that times a negative 1/2, it does check. So yes, we can draw this line for our equation. One of the last things that we're going to be taking a look at, the last couple of things, is what is the equation for a line? And can we put it in slope-intercept form? In the next problem that you're looking at, you're using 2 points to write an equation. So first off, what is an equation of a line? What is the equation for the line at the right? Key thing, how do we want to leave our answer? Our answer, at this point, we're not going to use the slope-intercept form, so we're not going to use the y equals mx plus b. We want to use this new form. First thing, we know 2 things. We know we have the point at negative 2, 3 and a point at 1, 4. Since those are our 2 points, we want to find the slope. To find the slope, we're going to take our second y-coordinate, which is 4, minus a negative 3. So we have 4 minus a negative 3 divided by, in our denominator, we're going to take our x-coordinate of our second one, which is 1, and we're going to take 1 minus a negative 2. This first one, when we take a look at the point, if we're rewriting that, we're going to have 4 plus 3, which gives us 7. 1 minus a negative 2 becomes plus 2, and we're going to have the slope of 7/3. Now we're going to go to our equation. Again, we're not using the slope-intercept, we're using point slope, and we are using that first point, negative 2, 3, to write an equation. So we start, as you do your homework, make sure you write this down first. Y minus y1 equals m times the parenthesis x minus x1. What is our y point? Our y1 point is negative 3. So we're going to put minus a negative 3. Our slope was 7/3 times x, and it's going to be minus our x-coordinate, which is negative 2. Now again, we don't want to leave minus a negative in our equations, so when you rewrite your equation, it'll be y plus 3 is equal to the slope, 7/3, times the quantity, x, plus 2. And you are done writing your equation. How can you use a table to write an equation? One of the first things we do is we're looking at this table. This is our x time and altitude, y, and in this case we are talking about in miles. Could be meters, 640 possibly meters would be my guess. What is the equation in slope-intercept form that gives the balloon's altitude and time? It says first, hint, write an equation in point slope form and then convert it. One of the first things you can easily do is you can check what is your slope. You're going to take your change in y divided by change in x. So m first, we need to find our slope. And in this case, if we take 590, our second point, and subtract 640, divided by 30 was our time in seconds, 30 seconds minus 10 seconds. We're going to subtract those two, and you should get the decimal, negative 2.5. Hopefully it makes sense that you're going to have a negative. You should have a negative number divided by 20 here. It gives you negative 2.5. Next, we're going to go to our point slope form of our equation. Y minus y1 equals slope m times x minus x1. And again, as you look at that, easiest to use the very first point. So if we are taking a look at it, we're going to have y minus, our y coordinate would be 640, equals slope negative 2.5 times x minus 10. Now, when you get it in slope-intercept form, we're going to use the distributive property here. So y minus 640 equals negative 2.5x, and you should have plus 25. In this case, when you're multiplying 2.5 times 10, we're going to add 640 to both sides. So our equation in slope-intercept form is going to be y is equal to negative 2.5x, and we should have plus 665. What does the slope and y-intercept tell us? Our slope should be telling us that our balloon is going down minus 2.5, and in this case we are talking about meters per second is how far it's going down. The video is almost over. What is this? You may want to pause the video to get what the slope and the y-intercept, what they mean in this problem. In class, we will be working on your homework.